You
Good.
doing good?
Okay, so we're on to trapezoids and kites, right? Is
Yep, we are.
that what you did today? Or you had a test today?
Oh yeah, we had a quiz today.
I hope the quiz
hmm
wasn't on trapezoids and kites.
Oh, it wasn't. Yeah, don't worry.
Okay, because after our session last night, I started thinking, wow, he's having a quiz on trapezoids and kites, and we were only up to rhombuses and parallelograms.
No problem.
Okay.
Yeah, we just did what we worked on last night. So.
Because I feel like you actually have a good understanding of congruent triangles, rhombuses, parallelograms, squares, and rectangles.
Uh-huh. Yep.
Okay? So
Okay.
trapezoids and kites, well, these are different. Hold on. Let's see.
Okay.
Um,
Yeah.
a kite.
hmm
Let's talk about a kite because it's kind of the closest to the quadrilaterals we've been dealing with.
Okay.
Okay, the definition of a kite
Uh-huh.
is two adjacent sides are the same.
hmm
Those two are the same.
Okay.
Okay? In other words,
Okay.
we don't have four equal sides like a rhombus.
Uh-huh.
We don't have any parallel sides like a parallelogram.
Okay.
We don't have 90-degree angles.
No.
But if you take this kite and draw diagonals, they will be perpendicular.
Okay.
Okay? And that's the most important thing. And secondly, one diagonal, the long one, bisects the other,
Okay.
but not vice versa. In other
Okay.
words, that is equal to that, and I should use a triple hash mark because it's not equal to any of these other,
Yeah.
but this piece here is not equal to this long piece here.
Okay. Yeah, that makes
The
sense.
best way to think of kites is to elongate it like this. In other words, don't draw your kite like this.
No.
When you draw your kite like that, it looks too much like a rhombus.
Exactly. Yeah.
Okay? Now, the other property of kites
hmm
is that opposite angles
hmm
has exactly one pair of opposite angles. Only one.
Okay.
This one
hmm
and that one.
Okay. Yeah.
This angle here is not congruent with that angle. As you
Okay, now.
can see if you elongate it.
Uh-huh.
Words, as long as you draw it elongated, you can tell that. It's only
Okay.
if you draw it to make it look like a rhombus that you could come to the other conclusion. But no matter
Yeah.
how you draw it, this angle here is always equal to this angle here. And in
Okay.
fact, that's all you need to know about a kite, is that that angle's equal to that angle, this side's equal to that side's equal to that side, and their intersection is
Is perpendicular.
perpendicular. There's one other nice formula. What's the area of a kite?
The area would be, ooh, I don't know this one.
Really easy. It's 1/2 the base times the height.
Oh, okay.
Okay?
Okay.
Notice that a rectangle is the base times the height.
Uh-huh.
Well, what if I were to draw a rectangle about this kite? Notice my base and height are those diagonals.
Okay.
Okay? So
Okay.
the area of that rectangle would be base times height, my diagonal 1 times diagonal 2.
Okay.
And
Yeah.
the area of the kite is pretty clearly half the area of that rectangle. In other
Uh-huh.
words, if I look in that section, that's half. If I look in
Uh-huh.
this section, that's half. If I look in this area, that's half of that little rectangle, and that triangle is half of that rectangle. So
Okay.
if you're trying to figure out area, realize that it's not going to be the area of the rectangle that surrounds it, but half of that area.
Mm-hmm.
the rectangle that surrounds that kite is obviously bigger than the kite. So
Yeah, for
if
sure.
you remember the area is either base times height or 1/2 base times height, then you can't get it wrong.
Okay,
In
cool.
fact, it's kind of the area, it's the same as the area of a triangle. The area of a triangle is 1/2 base times height. The area of a kite is 1/2 the diagonal 1 times diagonal 2.
Okay,
And diagonal
cool.
1 is my height, diagonal 2 is my base.
Okay, cool.
Okay,
Alright, awesome.
okay, let's talk about trapezoid. We're going to go back to kites here because I still have 2 pages that have problems on here.
Sweet.
But trapezoids are also quadrilaterals.
hmm
The thing about a trapezoid is it always has one opposite pair of parallel lines.
Okay.
Never two.
No.
In other words, if this line is parallel to this line, then you have a parallelogram. You don't have a trapezoid.
Okay.
Okay?
Uh-huh. Okay.
The area of a trapezoid. Well, if that were a rectangle, it would be base times height, right?
Uh-huh. Yep.
But in this case, I have 2 different bases. This is base 1 down here. That's base 2.
Ooh, so would it be area is equal to base squared times height squared?
Well, not quite.
Or no?
Not
No.
squared, but it's the average base times height.
Oh,
Well,
okay.
what's the average base? When you get an average, you take 1, you add the other, and you divide by 2. That's
Uh-huh.
the average base.
Yeah.
Times the height.
Okay.
This is h, and
Uh-huh.
this is average base right there.
Okay.
Okay? The base that would be somewhere in the middle. But
Okay.
I don't know if it's exactly in the middle. Depending on the trapezoid, it can be down here, it could be up there. But you
Uh-huh.
always get the average base by adding your 2 bases together, dividing by 2.
Cool. Okay.
Okay? And that's a good way
Okay.
to memorize it because you know what the area of a rectangle is.
Uh-huh.
And a trapezoid looks quite a bit like a rectangle. You know,
Okay.
if I was trying to figure out the area of this trapezoid, I'd be looking for the base times some height. But the question is, I have 2 different bases. So it's
Uh-huh.
always, and the 2 bases are always the sides that are opposite one another.
Okay.
Okay, now, another thing about a trapezoid,
Mm-hmm.
we know all 4 angles have to add to what?
360 degrees.
And opposite angles are supplementary. Hold on a second.
Okay. Yeah.
Well, there is no angle theorem about trapezoids.
Oh, okay.
There's a special kind of trapezoid.
Uh-huh.
And that's one called an isosceles trapezoid.
Okay.
Okay? And an isosceles trapezoid is where that side's equal that side. It's a lot like an isosceles triangle. In fact, if
Uh-huh.
I carried these vertical lines forward, I would have an isosceles triangle.
Mm-hmm.
So you can kind of think of it as in the same manner as an isosceles triangle. But when you have an isosceles trapezoid, that angle is equal to that angle.
Okay. Yeah.
Also, the diagonals are congruent, which would
The
make
opposite sides.
sense.
Opposite.
They don't bisect one another, but they are congruent. They're the same length.
Okay. Yeah, that makes sense.
All right, so let's look at some of
Okay.
these problems.
Okay.
Again, these are from your book.
Mm-hmm. Yeah.
And we don't need to do 1. I think you understand 1.
Uh-huh.
Describe the differences between a kite and a trapezoid. I don't think we need to do that.
Mm-mm.
That's a verbal problem.
Uh-huh.
This one, 3 through 6.
Okay.
If I'm trying to figure out whether it's a trapezoid or not,
Uh-huh.
let's look at just 3.
Okay.
If I plot these points,
Uh-huh.
0, comma 4,
Uh-huh.
4, comma 4,
Mm-hmm.
8, comma minus 2, and 2, comma 1. Connect the dots. Is that a trapezoid?
Nope.
How would,
No, you can.
how would I know?
Well, you would first have to, like, identify the slope.
There you go. That's the key.
Yeah.
This slope actually looks pretty similar to this slope here.
It does, yeah.
Okay?
Uh-huh.
And so this might be a trapezoid. Let's
Uh-huh.
figure out the slope. What's the slope from this point to, let's see, this point here is 2, comma 1. What's that slope?
That slope would be, uh, up to,
Okay, take the rise over the run.
yeah, right. So,
What is the rise?
oh, wait.
Difference in the y coordinates.
Down to over 3.
It's down 3 over 2.
Down.
In other words, this is the y coordinate.
Oh, yeah. I was looking at it backwards. My bad.
Okay? So
Okay.
I'm subtracting the y coordinates. So 4
Uh-huh.
minus 1 over
Mhm.
0 minus 2. So
Okay.
minus 3 halves. And that agrees with what we see. We're looking at a negative slope, so we better have a negative number.
For sure, yeah.
Okay, so that's minus 3 halves. Now let's look at the slope from this point, which is 4, comma 4, to this point down here, which is 8, comma minus 2. What is that slope?
So that would be -6, 8.
No, remember
Negative,
it's
negative.
slope. This is the most important thing you can know about geometry. Slope is the change in y over the change in x. Rise over run.
Uh-huh.
This converts to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1.
Okay.
What is y sub 2 minus y sub 1?
So y of 2 minus y of 1. So that would be 4 minus, so it'd be 4 minus a minus 2, right?
Well, that's y sub 1 minus y sub 2.
Oh, okay.
That's okay. You can go in that direction as long as you go in that direction on the x also.
Yeah.
But
It would
better way is to just follow the formula.
y. Yeah, y over 2. So, or y2 minus y1.
Minus 2 minus 4 is the change in y. That's y sub 2 minus y sub 1.
Yep, and then it would be 8 minus 4.
Okay. What does that equal?
That is equal to -6 over 4.
Which is the same as negative 3 halves.
Yep.
That is a trapezoid.
Uh-huh.
So all you need is to find the same slope for opposite sides.
Okay.
Okay?
Cool. Okay.
All right, sticking with the thing we can do now that we didn't used to be able to do, and that is, let's do another problem
Okay.
of the same type.
Okay.
It's problem 4. Is that a trapezoid? Well, really helps to draw a picture here.
Yeah, for sure.
Okay, minus 5, 0 is right there, and label those points because we know we're going to have to find slope between two of them. 2 comma 3 is right there.
What are you doing?
3 comma
What?
1 is right there.
Uh-huh.
And minus 2 comma minus 2.
Uh-huh.
That's about right there.
Yeah, that's about right.
Again, I can't really tell from my picture whether that's a trapezoid because I've approximated all my drawing.
Yeah, exactly. It's kind of hard without like graph paper.
So the only way to do it is if either this slope is equal to this slope, which would make it a trapezoid, or that slope is equal to that slope.
Yeah.
So let's examine both. What's the slope of this line here?
The slope would be 2 comma or 2 over -1.
So negative 2.
-2 over 1 maybe, yeah.
What's the slope of this point here?
That would be those two, so it would be wait, which ones are we looking at? -5, 0, and then -2.
Yeah, and that point.
-2. Okay. So that one would be -2, -7. Or negative wait.
Well,
Oh, that's hard.
well, it's not really that hard. In other words, plug it in. Don't try to do all of that in your head. Plug in y sub 2. Y sub 2 is minus 2. Minus 0. That's y sub 1.
Yeah.
Now, just make sure you go the same direction. So we have to do x sub 2 minus x sub 1. Don't drop any negative signs.
Nope.
And
then
what we get is minus 2 minus 0 is minus 2.
Over plus 3.
Over plus 1.
Plus.
In other words, minus 2 minus a minus 5 is the same as minus 2 plus 5, which is plus 1. Which is minus 2. Same slope.
Okay. Minus 2 minus a minus 5. Wouldn't that be 3?
Oh, excuse me. Sorry.
Oh, no, you're good.
No. Thank you. Actually,
yeah.
You know, when I first did this problem, I said those two slopes aren't the same. And then when I did the math, I just convinced myself that that was a plus 1. But no, you're absolutely right. It's plus 3 in the bottom.
Okay.
So the slope of this line is not the same as the slope of this line.
No.
So it's not a trapezoid because of that, but we've got the other two sides to examine. So now we have to figure out what the slope of this line is and what the slope of this line is.
Okay.
So what's the slope of this line?
Of that line, so...
The top line.
Oh, the top one, okay. So that would be 3...
Plug it in, yeah, just plug in the numbers.
Yeah, 3 minus 0, and then 2 minus -5, minus a minus 5. And then that would be 3 over 3.
What's this?
Or -3, my bad. Well, no, that'd be... oh my gosh, 7. My bad. I
So
keep thinking
that's a positive slope, as it better be, because we're looking
Uh-huh.
at a positive slope, right?
Yeah. Yep.
Okay. Now, what's the slope of this line?
So it'd be 1 minus 2.
1
Oh,
minus a minus 2.
is
Don't,
that a minus 2?
yeah, sorry, I covered it up.
Okay. No, you're
One of
good.
the easiest mistakes to make in algebra is dropping minus signs,
Yeah.
okay? Especially when you have a string of them.
hmm
But obviously that's a minus 2 divided by what?
Divided by 3 minus a minus 2.
What is that number?
That'd be 3 over 5.
Is not the same as 3 over 7,
Nope.
so this is not a trapezoid.
No.
In other words, we do not have a pair of opposite sides that are parallel.
Nope.
That's the definition of a trapezoid. So
Okay.
this is just a straight old quadrilateral. No
Okay.
special designation.
Yeah.
All right. I don't think we probably need to do 5 or 6.
No, I don't
So
think
that's
so.
not
Yeah.
bad practice. In other words, if you really are not sure that you have this understood,
hmm
then you should do 5 and 6.
Okay. Yeah.
As far as you and I are concerned, let's go on though. I think you have it down as long as you know how to figure slope, and that's
Me
what
too.
trapezoids are all about, really.
Yeah.
Okay, so here we have what? Yeah, that's a trapezoid. Why?
That's trapezoid because 2 of the 4 sides are supplementary.
Parallel.
Parallel, yeah.
In other words,
Okay.
KL is parallel to JM. That's all you need to make it a trapezoid.
Uh-huh. Yeah.
Number 8, JM is parallel to KL. That's all you
Yep.
need to make that a trapezoid. And in number 9, LM is parallel to KJ. That's all you need
Yep.
to make it a trapezoid.
Okay. Cool.
Okay? Now, for isosceles trapezoids,
Uh-huh.
which this one is,
Yeah.
because that side is equal to that side. In other
Uh-huh.
words, your two non-parallel sides are equal.
Uh-huh.
Well, we know this angle is the same as that angle. We know
Uh-huh.
this angle is the same as this angle. And we
Mm,
know that adjacent angles are supplementary,
exactly,
but
yeah.
only for isosceles trapezoids.
hmm
So what's the measurement of J?
The measurement of J would be 130,
L
50,
and M.
130.
Okay, and number 8, what's the measurement of J?
100.
Does it look like a 100-degree angle?
Doesn't say, what you, oh, it'd be 80 degrees.
Okay.
Because you do 180 minus
Right.
100.
In other words, adjacent are supplementary, not equal.
Yeah. Yeah.
Which is the
Okay.
100-degree angle?
Angle M.
Does it look like 100 degrees?
Well, no. So it'd have to be angle L. That looks like 100 degrees.
Correct. Correct.
Yeah.
In other words, it's adjacent angles that are equal in isosceles trapezoids.
Uh-huh.
That one is equal to this one,
Yeah.
and this one is equal to this one.
hmm
Even though I don't believe they've actually drawn it. I'm trying to put my head on its side and look at that. And it doesn't look to me like this angle is equal to this angle, and I don't think it actually is, but according to them it is, because they've labeled this as an isosceles trapezoid.
Uh-huh. Yeah.
Okay, same thing here. What is angle J?
Angle J would be 118.
Angle L?
180 minus 118. That would be 98
Oh, hold on.
or
I'll
92.
teach you this trick.
Okay.
When you are subtracting a number from 180,
hmm
which you have to do repeatedly in geometry,
Yeah.
do that part first and subtract 1. In other words, that's going to be 6.
Okay.
6 and 11 have to add to 17. And the next part's easy.
Okay.
In other words, do it the opposite way you would do it if you were actually doing it on paper. If you were doing it on paper, what would you do? You would borrow 1
Yeah.
and subtract 10 minus 8 to get the 2. And then you would have 17 minus 11 to get the 6. So whenever you subtract a number from 180 that does not have a 0 as its last digit, then these two always have to add to 17.
Okay.
Not 18. So the quick way to do these, just find the complement of 17. Well, that's 6, right? I'm looking for the complement of 17 from 11. That's 6, and then I know that's really easy to come up with. The complement of 10 from 8 has to be a 2.
Yeah.
8 and 2 add to 0. So that's the easy way to do it. So 62 is the answer for that angle. What's this angle here?
Angle J is 118.
And this angle here?
That was 62.
Okay.
Yeah.
Is that a trapezoid?
No. Well, yeah, it would be because, well, actually no, it wouldn't because the two sides aren't parallel.
Well, I only need one set of parallel lines. AB appears to be parallel to DC.
Yeah.
But the key information is the fact that that angle is equal to that angle, and this angle is equal to that angle. Not only is that a trapezoid, that's an isosceles trapezoid. In other words, this side here is equal to this side here.
Okay.
Okay, now, and remember, with isosceles trapezoids, you have adjacent angles that are equal. Well, it's not really proper to say adjacent angles because A and D are also adjacent. But A is equal to B and D is equal to C. That makes it an isosceles trapezoid.
Yeah.
Now, 11, is that a trapezoid? It's clearly not an isosceles trapezoid, but is it?
No. I don't think it would. No, it wouldn't be because.
Okay, let me draw a picture here.
Yeah.
Remember our theorem about parallel lines. If I have two parallel lines, and this angle is equal to this angle, that tells me those lines are parallel.
Yeah.
In other words, it's not just that if I have two parallel lines, those angles are equal. It's if those angles are equal, I have two parallel lines. In other words, if you tell me this angle is equal to this angle, then I can say those two lines are parallel.
Okay.
Well, up here,
that's 90 degrees there.
That and that are 90 degrees, both of them. That means all four of them are 90. Which makes those two lines parallel.
Okay. That makes sense. Okay. And then number 12 would be a trapezoid because because ML is parallel to JK.
And that's all you need.
Yeah.
You don't even need to know that this angle is equal to this angle. So all I need to know is that that's parallel to that. That makes it a trapezoid. Actually not.
It's not?
No. This is kind of a strange question. In other words, because this is equal to that, it also makes JM parallel to KL.
Ah, okay.
Notice that if I eliminate that and just consider that a transversal,
Uh-huh.
then that is equal to this angle here, which is equal to that angle. So JM would have to be parallel to KL in addition to JK being parallel to ML.
Oh, okay.
Figure 12. It's a
So
parallelogram,
that makes sense.
not
Yeah.
a trapezoid. In other words, one of the definitions of trapezoid is one and only one pair of parallel lines. So
Mhm.
if I have something that looks like this, well, if I know that's parallel to that, it looks like a trapezoid, but it's not a trapezoid if that's parallel to that, it's a parallelogram.
Uh-huh.
And that's the only case where it's incorrect to call a trapezoid, is if
Okay.
it's a parallelogram. It's a little different than calling a square a rectangle.
Uh-huh.
In other words, a square is a rectangle.
A square is one, yeah.
Okay, a square is a rectangle.
Uh-huh.
Because a definition of a rectangle is opposite sides are parallel and every angle is 90 degrees. That's the
Okay.
definition of a rectangle.
Yeah.
Now, that
Yeah.
definition also applies to a square. So
Okay.
it's proper to say that a square is a rectangle. But
Uh-huh.
it is not proper to say that a parallelogram is a trapezoid.
Okay.
It's not.
Yeah.
If you have two pairs of opposite parallel sides,
Uh-huh.
it's not called a trapezoid. It's called a parallelogram.
Okay. Cool.
And that's actually a subtle difference.
Uh-huh.
Very
Yeah.
subtle when I think about it.
Yeah, exactly.
Logically, you would think that it would be the other way around. You would think that a trapezoid actually would also be a parallelogram.
Yeah, you would think so.
Yeah, but
Uh-huh.
it's not. Okay.
No.
So
Okay.
find the length of the midsegment of the trapezoid.
Okay.
Number 13.
Let's see. So find the length of the midsegment. So the mid segment. Gosh, I can't talk. Would be 14.
Yeah. Notice that the mid segment is the average base.
Yeah.
It's that plus that divided by 2.
Exactly.
And it always is in a trapezoid.
Uh-huh.
As long as you're dealing with the line going bisecting that side and that side. In other words, as long as this line bisects the two non-parallel sides,
Mm-hmm.
you have a mid-segment.
Okay.
What's this one?
So that one would be 23.
And I'll bet you did this the way I did it. You did not add these two numbers together and divide by 2.
Nope.
You found the difference was 4, cut that
Uh-huh.
in half, added 2 to 21.
Yep.
Okay, good. I like that. I like that way better.
Cool. Yeah.
And here? Not so easy to do here, because now we have to take half of 19 and add it to 57. So it's a little tougher to do the arithmetic on 15. So
Yeah.
let's do it the regular way.
Yeah, 6 and a half. Okay.
And that is 19 and a half more than that.
Uh-huh.
In other words,
Okay.
the difference between these two numbers is 19.
Okay.
I meant 19 halves more than that.
Yeah.
All right, I love these kind of problems. Which statement is not always true? The base angles of an isosceles trapezoid are congruent. True or false?
Uh, which one is not always? That would be,
Forget the question.
yeah. So for we're on A, right?
Answer my questions. Is
Okay.
the base angles of an isosceles trapezoid, are they always congruent?
Yes.
Okay? So that's always true.
Uh-huh.
The mid-segment of a trapezoid is parallel to the bases.
That's not always true.
Well, in the pictures we were looking at, it is. In other words, notice that for that to bisect that side and this side, it has to be parallel to these two parallel bases.
Yeah, that's true.
Same
So that would always be
here.
true then.
Same thing here. Over here, the bases are this side and this side.
Yeah.
In other words, your
So
bases
it would
are not
always be true.
horizontal. Sometimes your bases are vertical,
Uh-huh.
but the mid-segment is always parallel to both of those parallel bases.
Yeah.
So that's always true.
Uh-huh.
The bases of a trapezoid are parallel.
No. No.
Well, yes, that's the definition of a trapezoid.
Oh, it is?
Uh-huh.
Oh, yeah, that's right. Yep.
It's just that the bases are not always the horizontal ones. In other words,
Uh-huh.
if I look at this trapezoid up here, the bases are this vertical line and this vertical line.
Yeah.
Those are the bases.
Uh-huh.
So you kind of have to know the definition of bases to know the answer to this. But
Yeah.
yes, the bases of a trapezoid are parallel.
Okay.
The legs of a trapezoid, and when they talk about the legs, they're talking about the two sides that are not parallel.
And that would never be true.
Well, sometimes it would be true if I have an isosceles trapezoid.
Not always. So,
Right,
yeah.
not always. But if I have a precise isosceles trapezoid,
Uh-huh.
that leg is congruent to that leg. And
Yeah.
that angle is congruent to that angle. But
Uh-huh.
anything that's not an isosceles trapezoid, in other words, if I make my trapezoid like this,
Uh-huh.
now that leg is not congruent to that leg.
No.
So it's,
Clearly,
yeah, that's the
Mhm.
one that's not always true.
Okay.
Sometimes the toughest part about these problems is figuring out what the heck they're trying to say here, which
Yeah.
is not always true. Talk about a double negative. No, I guess a double negative would be which statement is not always false. That would
Yeah.
be tough.
That would be.
A double negative.
Okay.
All right. And let's see. Describe and correct the error made in finding angle A.
Okay.
And he says that opposite angles of a kite are congruent, therefore angle A must be 50 degrees.
Yeah, it must be.
Is that true? Are
Uh-huh.
opposite angles of a kite congruent?
Opposite legs. No, it's not always true.
Well, one pair of opposite angles are always congruent.
Yeah, not two,
Pair
though.
here, but not this pair here.
No.
If
And it doesn't look like it either,
no,
that they're...
exactly. This is one you can tell by inspection. Even
Uh-huh.
though they haven't drawn it correctly. In other words,
Yeah.
they haven't even drawn a proper kite there. If I connect A to C and connect B to D, I don't even have perpendicular lines, I don't think.
Exactly.
But,
Yeah.
so D is 120.
Mm-hmm.
And we know the sum is 360. So I could figure out what A is. But I can't just assume that A is 50 because it's an opposite angle. Opposite angles of kites are not congruent except for one pair of them.
Yeah. Mm-hmm. Okay.
And quads D.
Okay.
This will take us through tonight, I think. Yeah, we only got 18 minutes. But it won't take us through tomorrow night.
Okay.
So I need more problems. I guess I can just go to the book as long as you tell me. As long as you tell me what subchapter you're doing, I can always go to the book and come up with problems.
For sure, yeah.
So we're good to go there. But
Cool.
All right. So if 18 is a kite, what is angle G?
So if 18 is a kite, then what's measure of G?
G is equal to which angle?
G would be equal to 100.
Well, no. Which one? Which other angle on that kite?
Oh, okay, yeah, angle E.
Okay. Now, what do I know about all four angles?
We know that they all have to add up to 360.
So H, which is 100, plus E plus G plus 40 have to add to 360.
Uh-huh.
So E plus G have to add to 220.
And then
They're both
that's
equal to one another. So 2E has to add to 220.
yep,
What
and
does angle E have to be?
110.
And that's the same for angle G.
Yeah.
And a quick inspection, they look 110.
They do, yeah.
In other words, if I'm looking at an acute angle, I did something wrong in my math.
Yeah, exactly.
Always worth doing that check. Always in geometry.
Uh-huh.
Because you can, a lot of times, catch errors
Yeah.
that you might make.
Exactly.
Alright? Let's angle
Okay.
G here.
Angle G for 19, right?
Uh-huh.
So angle G would be 60 degrees.
No.
Ooh, actually, no, we don't know that. So, what we would do, 360 minus 170.
Well, hold on. Remember that a kite does have two opposite angles that are equal. You just have to find them.
Yeah, it'd be
Not
H and
E,
F.
yeah, it's not E and G, it's F and
No.
H.
Yeah, exactly.
F and H. That's funny. It's frickin' H. That's that.
Yep. Yep.
So that's 60. That's 110. That's 110. So what does this have to be?
It'd be 220 plus 60, 280. 360 minus 280 would be 120 minus 280. So that would be a 180. Yeah, 180.
Just
or just 80.
Just 80. In other words,
Yeah.
when I borrow the 1, it makes that 2.
Mm-hmm.
But
Yeah.
when you're doing subtraction,
Mm-hmm.
add those two together again. Make sure they come out to what the first number is.
Okay.
If you came out with 180 and you add those two together, you come up with 460.
I'm sorry. Can you repeat that? My brother was yelling in the
In
background.
other words, your first answer was 180.
Uh-huh. Yeah.
And notice that when I add 180 to 280, I don't get 360.
Nope. You get 460, yeah.
So when you're doing subtraction, especially without a calculator like that,
Uh-huh.
always do a quick check to make sure those two add to that one.
Uh-huh. You can always double check it, yeah.
Yeah, it's always good in all math.
Uh-huh.
One of the reasons I've actually been able to get by without using a calculator very often is because by force of habit, I always do the check.
Okay.
Okay? Because for so long I didn't have calculators. And
oh yeah, for sure.
if you wanted to ensure your accuracy, you had to add these two back together again to make sure you got that.
Uh-huh. Yeah.
How about number 20?
Number 20 would...
H is 90.
Yeah, so H would be 90, F would be 150. 150 plus 90 is...
240.
240, yeah, and then you do 360 minus 240 divided by 2.
Good.
Which would be 60, yeah.
I actually prefer it when you give me the answer as 120 divided by 2.
Okay.
Because that shows me you understand exactly how to do it.
Yeah.
As opposed
Exactly.
to if you told me 60, you might have come up with 60 any number of ways. Notice that you would get 60 if you took 150 minus 90.
Yep. Yeah.
Okay? So
True.
just telling me 60 doesn't really tell me that you know how to do it. But
No, it doesn't.
added those two to get 240, and now you subtract 240 from 360 and divide by 2, I know you know exactly what you're doing.
Okay. Yeah.
Okay.
Okay.
Kites apply, the Pythagorean theorem applies for kites because the diagonals of kites are always right angles.
Yeah.
Three of these kites, the diagonals make right angles. They intersect at right angles, just like a rhombus.
Uh-huh. Yeah.
Okay? So,
Okay.
what we're looking at here is 4 right triangles.
4 right triangle. Okay.
Now, it says find the side lengths of the kite.
Okay.
So, good. We get to practice your Pythagorean theorem that we worked on last night.
Sweet.
This triangle right here, what is that hypotenuse equal to? Start your answer with what?
A squared plus B, or no, it's
Square root
A.
of.
Yep, exactly. Yeah.
So what is it the square root of?
3 squared?
Plus,
3 squared plus 5 squared.
no, we're looking at this triangle right here. The
So it'd be
sides are 3 and 3.
Okay, so it'd be 3 squared plus 3 squared.
Okay, what is that number? So square root of what?
The square root of not wait, so it'd be the square root of 3 squared plus 3 squared plus
No.
5 squared.
That's it.
Well, no.
What's the square root? Okay, you got it right. WX equal to the square root of the two sides squared.
Yeah. Okay.
The square root of 18. Square root of 9 plus 9.
9 plus 9. Okay.
Okay, now
okay.
square root of 18 can be simplified. How? Simplify that. Let's review algebra.
Okay. Well, you can't simplify.
You gotta factor it. Can you factor 18 such that one of the factors is a perfect square number? That's the trick.
Yeah. Yeah, 9.
Okay, so it's the square root of 9 times the square root of what?
2.
What's the square root of 9?
3.
So the answer is 3 root 2. That's what the square root of 18 is.
Okay.
And that's the dimension of that.
Okay.
What's xy equal to?
Let's see. Xy would be the square root of 3 squared plus 3 squared.
Same thing, right?
Yeah, same thing, yeah.
So 3 root 2.
Uh-huh.
How about WZ?
That would be the square root of 3 squared plus 5 squared.
Which is?
Which would be...
In other words, sometimes I like that answer, but the teacher's not going to like that answer. In other words, I like that answer because it tells me you know what you're doing. But
yeah, exactly.
It wants a final answer. What is that number, the square root of? And I don't mean decimal. I mean leave it in radical form. So it's the square root of what? 9?
9 plus 25, yeah.
34. Now, can I simplify that?
You could do...
I have to find a factor that's a perfect square. That's the only way to simplify.
Yeah, trying to think here.
Let's see if we
can't.
No.
Well, 17, but that's not.
Okay. So you're on the right track though.
Yeah.
Okay. Why do I know that 34 can't be simplified? Because
17 is not a perfect.
They're both prime numbers.
Yeah, exactly.
If I've got two factors that are prime numbers, those are the only two factors of 34.
Okay. Yeah.
Which means there is no factor of 34 that is one of your perfect square numbers. Remember, the perfect square numbers that we're looking for are these.
Okay.
That's 2 squared, 3 squared, 4 squared, 5 squared. Well,
Uh-huh.
none of these is all you have to do is try to divide 34 by one of those four numbers, and you
Hmm.
can see that they don't divide evenly. None of them.
No.
That will tell you. And I don't need to really go beyond 16 because 16, well, I do need to go one more. I need to go to 25. But 25 is more than half of 34. So I don't need to check anything above the 25s.
Hmm.
If
Yeah.
none of these four divide into 34, then 36 isn't going to, and 49 isn't going to.
No.
See what I'm saying?
Uh-huh. Yeah, for sure.
So the answer is root 34.
Cool.
You don't want to give this as the answer. That's more complicated. That's
Yeah,
two
for sure.
terms instead of one. The only time you simplify radical is if you can pull out a whole number.
Okay. Yeah.
Okay, so what is this side, WX?
WX would be the square root of 6 squared plus 4 squared. And then that would be the square root of 36 plus 6, the square root of 16.
Is that
And then,
simplifiable?
no.
Okay, the one thing I always do to see if it's simplifiable is see if it's divisible by 4. The very
Hmm.
smallest perfect square number.
Okay.
I know it's not divisible by 9,
Mm-mm.
and it's not divisible by 16, but
Uh-uh.
it actually is divisible by 4.
Oh, okay. That'd be, yeah, 13, okay. Yeah.
Means this is what?
The square root, or just 2 square root of 13.
That's the
Yeah.
correct answer.
Okay.
Okay. What's
Hmm.
xy?
XY would be,
After a while, you get pretty good at doing. In other words, what I attempted to do last night with you was
hmm
teach you how to solve right triangles without going back to this.
okay.
Everybody can do that, but it
hmm
takes a long time to solve
Uh-huh.
A, B, and C here.
Yeah.
So if you have that advanced method that I taught you last night, where you can go straight to it, then
hmm
it really makes solving these much easier. What's this the square root of? XY.
Uh, yeah, so it would be 6x, or 6 squared plus 12 squared. So that'd be
So that's
30 squared.
36 plus 144, that's 180.
hmm
Square root of 180. Is that simplifiable?
Yeah.
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 Let me give you another clue. Any number is divisible by 4 if its last two digits are divisible by 4.
Exactly. Yeah.
So I know that's divisible by 4 because 80 is divisible by 4.
hmm
Now,
Yeah.
is it divisible by 9?
Yeah, it is.
Any number is divisible by 9 if the sum of its digits add to 9.
Uh-huh.
You
Yeah.
add to 9. So yeah, that's divisible. That's the square root of 9
hmm
times the square root of 20.
Okay. Cool.
Okay? So that would be 3 root 20, but is that simplified?
Nope.
Okay?
No, yeah.
That's 3 times what?
5 times 4.
So what's the final answer?
3 square root of 5 to 2.
Well,
So just,
multiply the 2 times the 3.
which would be 6. Okay.
Okay?
Yeah. Okay.
And all of these are relatively simple Pythagorean problems because every case you're solving for the hypotenuse.
Yeah, exactly.
The Pythagorean, the method that we worked on last night is really actually a little more valuable for when you're solving for one of the sides
Okay.
because then it becomes a little tougher.
Yeah, for sure.
When you're solving for the hypotenuse, we know that c squared is always a squared plus b squared, so c is always the square root of that.
Okay.
So it's pretty
Yeah.
easy solving for the hypotenuse. What's
For
a
sure.
little
Yeah.
harder is solving for either A or B. And that's
Okay.
where, when you know the simplified version, it makes it a little easier. So what's xy?
So that would be the square root of 10 squared plus 5 squared. So that'd be 125, and then
Not
fifth.
divisible by 4,
No,
not divisible by 9, not
no,
divisible by 16. Is it divisible by 25?
it is. Yep. So yeah. So that'd be the square root of 5. Yeah. hmm
So what's the answer?
So that'd be the square root of 5 to the square root of 5.
No. What's that?
Or just 5 to the square root of 5, my bad.
5 root 5.
Yeah.
And WZ?
That'd be the square root of 19 plus the square root of 10.
Okay. And I won't go through that math.
Okay.
In other words, I know you know how to do it.
Oh yeah.
I'm going to give you one quick one just to test you.
Sure.
What's X?
That would be,
Give it to me. Don't give me a number. Give it to me how you would do it.
you would just,
What's the first words?
the square root of. So you just, oh, my bad. Yeah, I remember this now, sorry. So you would do x is equal to 6 squared
No.
plus, or 7,
The bigger number has to be first.
yeah. So it'd be x is equal to the square root of 17 squared plus 6 squared.
Not plus. When you're solving for
Minus.
one of the sides, it's always minus. And the way
Okay.
to remember that is, remember this has to be a bigger number than this, and there's a reason for that. It's because if it's not, I'm going to end up with a negative inside my radical.
Okay. Yeah.
Okay? So by that reasoning, you should remember that we're subtracting inside here.
Okay.
Always. And if we're subtracting, it has to be the hypotenuse squared minus the other side squared. And it doesn't matter. I could put the 6 down, or the 6 up there, and the x down here. It's the same thing. X is still the square root of 17 squared minus the other side squared.
Yeah. Yeah.
Okay?
Okay. Cool.
So these are a little harder because of that. In other words, you
Yeah.
have to know the order and which one goes first.
Yeah, you just have to
But the
kind of
key is to
remember.
always start off with square root of. If you do that, notice how that jogged your memory. In other words, the moment you said square root of, you knew what was supposed to go inside, or at least you were on the right path.
Yeah, I had a good idea.
Yeah.
Yeah. Cool.
Okay, 20,
Okay.
yeah, it's 6 o'clock, and I have a 6 o'clock tonight, so I got
Okay.
But
Sounds.
this is all the material I have. Okay, we can go even if you can't email me stuff. We can do it
Okay.
tomorrow. I'll see you at 5 tomorrow.
Awesome. Sounds good. I'll see you then.
Okay, Dylan. Bye bye.